Hi guys! Today we're going to talk about the calorific values of gaseous fuels. So this is a part of our lectures for chemical engineering calculations. Well, this topic is actually covered sa second part ng chemical engineering calculations wherein we are discussing about combustion of fuels. And on this lecture, we will be using this book, okay, which is the Stoichiometry of Fuel Combustion and the Related Process Industries by Evelyn Laurito. Well, I don't know guys if this book is still available sa National Bookstore, but for me, in my personal opinion, I really recommend this book, no? If you are taking chemical engineering course, so I would suggest to purchase this book. Well, the time na nag-aaral kami, we really use this book a lot, no, when we are studying about combustion of fuels. Okay, so marami kayong matututunan dito. There is a lot of solved problems and exercises na pwede ninyong magamit. So, ito yung gagamitin natin ngayong reference. And in fact, yung sasagutan natin is also a solved problem din dito sa book na to. Okay, so we will just going through the problem para makita ninyo kung paano natin nakuha yung mga values. But this solution is also included na dito sa book na to. Okay? So, let us begin. So, ano ba itong tinatawag nating calorific values of gaseous fuels? The calorific value or heating value of a fuel is the heat given off by the complete combustion of a unit quantity of a fuel at some reference temperature. So, reference temperature may be taken as 25 degrees Celsius, or for convenience, the ambient air temperature may be used. Okay, so yan yung tinatawag nating calorific values. And there are two types of calorific values. Meron tayong gross calorific value, GCV, or higher heating value, which is HHV. Meron din tayong net calorific value, NCV, or tinatawag ding lower heating value, LHV. So ano yung pinagkaiba nila? So, itong ating gross calorific value is the calorific value measured when the water formed by the combustion is in liquid state. Okay? While ito namang net calorific value is the calorific value measured when the water formed by the combustion is in gaseous state. Okay? So, nagkakaiba sila depende sa na-form na water natin if they are either liquid or gaseous state, no? Okay, so paano natin i-apply yan dito sa ating mga problems? So we have here for gaseous mixtures, we can get the gross calorific value with this equation, no? So the gross calorific value is equal to the summation of HCI times Ni. So ano yung HCI natin? The heat of combustion of component I, which we need to refer to Appendix 1. So, mamaya ipapakita natin yan. Kasi, para makuha pala natin yung HC, kailangan natin mag-refer sa Appendix 1. So, ibig sabihin, kung magsosolve tayo ng problem, we need to look for the value na nasa Appendix 1. Okay? So, dahil ginagamit natin itong book na to, so it's better na dito na rin natin kunin yung value natin. Well, of course, itong mga heat of combustion ng bawat component natin, pwede nyo naman makita sa iba pang mga reference book. Ito namang Ni is yung mole fraction of gaseous components. So, para makuha natin yung GCV, the gross calorific value, we need to get the summation of the product of the HC, which is the heat of combustion, and the mole fraction ng mga gas components natin, di ba? And for the net calorific value, we can get the net calorific value by subtracting from our gross calorific value itong moles of water from fuel combustion over total moles of fuel times LC of water. So, ano itong LC of water? Yung LC of water is the latent heat of condensation, which is equal to 44.04 megajoule per kilogram mole of water. So, calorific value units in SI are expressed on dry megajoule per dry SCM, or in wet basis, megajoule per SCM. At 15.56 degrees Celsius, 760 millimeter mercury, and 100% relative humidity. So, when a calorific value is given in a problem without specifying whether it is a GCB or NCB, it may be assumed to be the gross calorific value since it is this value which is usually reported. So, sinasabi niya kapag meron tayo na-encounter na problem, and given yung calorific value pero hindi minention kung ito ba ay gross calorific value or net calorific value, so you will use it as a gross calorific value because usually it is what is being reported. Okay, so yan yung mga basic definition natin for calorific values. So now let us now try to solve this problem. So we have to calculate the gross and the net calorific value of a natural gas. So gas itong pinag-uusapan natin at 25 degrees Celsius which has the following composition. We have 89.4% CH4, 5% C2H6, 1.9% C3H8, 0.4% IC4H10, 0.6% NC4H10, 0.7% CO2, and 2% N2. And we need to express that on these units, no? Pero hindi na natin sasagutan lahat yan. We will just solve for this one here. Okay? And one here para makita natin yung conversion niya. So, ito lang kasi conversion na lang naman ang gagawin natin sa mga susunod na requirement natin. No? So, papakita lang natin paano natin nakukuha ang ating GCV and NCV. No? So, we will solve this problem now. So, meron na tayong table dito. So, this is the same table na makikita ninyo sa book. Ano? Kaya lang doon, syempre, may mga sagot na yan. So, ngayon, ipapakita natin paano nakuha yung mga values na yon. Okay? So, first, we have to set our basis. Okay? Let me write it here. We need to find, okay, or we need to set our basis. So, kung makita ninyo, ang hinahanap natin is expressed in kilomole, no, or kilogram mole. So, it's better kung ang basis natin is mag-base na tayo sa per 1 kilogram mole. So, okay, let us set our basis as 1 kilogram mole para mas maging madali yung computation natin. Okay, 1 kilogram mole of natural gas. Okay, so yan na yung ating basis. Para kung ano man yung mga makukuha nating value, it is understood that its value is per 1 kilogram mole of our natural gas. Okay? So, paano natin makukuha ngayon ito? So, meron na tayong basis na 1 kilogram mole and given naman yung percentage ng bawat component natin. So, therefore, makukuha natin kung ilang kilogram mole ng ating components meron sa ating natural gas based from their percent composition. No? So, unahin natin itong methane, CH4. We have 89.4%. So, therefore, our number of moles of methane is 0.894. Okay? So, because we have 89.4% ng CH4. Now, we have 5% of C2H6. Okay, so since we have 5% of C2H6, that means we have 0.05 mole, kilogram mole. Para naman sa ating C3H8, okay, yung ating propane, our propane is 1.9%. So therefore, we have 0.019 kilogram mole. And para naman sa ating isobutane, which is IC4H10, we have 0.4%. So, therefore, we have 0.004. Okay? Okay, at para naman sa NC4H10, so we have here our N-butane, which is 0.06%. So, that means we have here 0.006. Para naman sa ating carbon dioxide, CO2, we have 0.7%, so therefore we have here 0.007. And para sa N2, we have 2%, so therefore we have 0.02 kilogram mole. Now, to be sure kung tama ba itong mga naisulat natin, just to counter check, baka nagkamali tayo ng pagkakasulat, we should add all of this at dapat this will be equal to 1 kilogram mole. Okay? So, it's not necessary, but we will just do it to make sure na wala tayong mali dito bago tayo magsimula. So, 0.894 plus 0.05 plus 0.019 plus 0.004 plus 0.006 plus 0.007 plus 0.02 and it is equal to 1. So, therefore, tama yung naging sagot natin. No? So, this is equal to 1.0. So, meron na tayong number of moles in kilogram mole ng every component natin. Now, the next step is to find itong HC natin. Okay? So, our HC is our heat of combustion, no? Of component I. So, bawat component natin. And we can get that to Appendix 1. Okay? So, I already have here a copy of Appendix 1. And minarkahan ko na rin yung mga components natin para hindi tayo mahilo sa paghahanap sa kanila, no? So, kunin natin yung ating mga heat of combustion. Unahin na natin itong ating methane, CH4. Okay? So, our methane CH4 is equal to 890.95. So, let us write that. 890.95. And for our ethane, C2H6. Ethane C2H6. So, this one. So, it's in gaseous form. 1,560.92. Okay. 1,560.92. For our propane, which is C3H8. Here, propane. C3H8 gaseous form. 2221.52. Okay. So, we have here 2221.52 for our isobutane. Okay, so this is our isobutane and dapat nasa gaseous form. So we have 2870.63. And for our N-butane, okay, so our N-butane C4H10 in gaseous form is 2879.01. Okay? So, tama ba? 2879.01. So, tama, no? Now, wala tayong makikitang CO2 and N2 dito sa Appendix 1. Okay? Walang carbon dioxide dyan and wala ring N2 because these are non-combustible material, no? So, we do not have values of that. Okay? Now, we don't need to get the summation of this because hindi naman yung kailangan natin yan, no? So, if you see our formula for gross calorific value, it is the summation of HCI, which is a heat of combustion of every component, multiplied to the mole fraction. So, ibig sabihin, we need to multiply this one to this one. Alright, so let us do that for every component natin dito, no? So, again, let us use our calculator. So, unahin natin itong nasa taas. 0.894 times 890.95 is equal to 796.51. So, I'll write it here. 796.51. Okay? So, next, itong ating ethane, we have 0.05 times 1560.92. Okay, so this is equal to 78.05. So I'm rounding it off in 2 units, no? So we have 156, we have 78.05. Okay? Next, dito na tayo sa pangatlo. 0.019 times 222.1.52. So we have 42.21. Okay, 42.21. 0.21. Okay, next, we have 0.004 times 2870.63. Okay, 0.004 times 2870.63. This is equal to 11.48. And then we have 0.006 times 2879.01. We have 17.27. Okay. And here, since wala tayong heat of combustion, so this will be 0, no? It will be 0. So now, if we can get this summation, we will be able to get our heat of combustion or our GCV, which is the gross calorific value, because ang formula for our gross calorific value which is gross calorific value. So our formula here, gross calorific value is equal to the summation of HCI times our number of mole of every component, no? So that means, since nakuha na natin to, no, itong product ng ating HC and N, this is the one that we are talking about. Kapag nakuha natin yung summation niyan, that will be our gross calorific value. So that means, nasagutan na kagad natin yung A. It is the gross calorific value. Okay? So, let us add itong mga values natin ng N times HC. Okay? So, 796.51 plus 78.05 plus 42.21 plus 11.48 plus 17.27, which is equal to 945.52. Okay, so actually that is our gross calorific value, which is 945.52. And ano yung unit natin dito? So our unit here is in megajoule per kilogram mole. Okay, so this is in megajoule per kilogram mole. Bakit yan yung unit natin? Because yan yung unit ng ating HC. And we are multiplying this actually sa mole fraction. So this is unitless, no? Nagkataon lang because we have a basis of 1 kilogram mole. Kaya itong ating number of mole dito, yan na rin ang ating value ng mole fraction, di ba? So ganun yung ating nakuha. So kuha na natin agad yung gross calorific value. Now, we can solve as well. Sabi ko nga, sasagutan din natin itong C, no? Okay, so you can get that, but first, you need to know the molecular weight, okay, ng ating natural gas. So, yung overall molecular weight na, ito yon. Kailangan makuha natin yung kanyang overall molecular weight, okay? Ito yon. Kasi ito yung molecular weight pala ito ng bawat component. And then, if you multiply that sa kanilang mole fraction, you can get and adding everything, so you will get the molecular weight ng ating natural gas. So, kapag nakuha na natin yon, we can multiply this or divide to our molecular weight para makuha natin yung unit natin dito, which is millijoule per kilogram. So, we need to get millijoule per kilogram. So, sasagutan natin yan mamaya. Okay? Kasi dadaanan natin yan when we are solving for the net calorific value. Okay? So, how about this at H? Okay? So, it means how many hydrogen we have, okay, on every component that we have here. So, for example, in our methane, CH4, we have a number of mole of 0.894 kilogram mole, di ba? But how many moles of hydrogen we have? So as you can see, we have 4 hydrogen present here. So we need to multiply this by 4. Okay, so let us say, let us calculate for that. So for our methane, we have 0.894. Ito yun. Okay, so we have 4 hydrogen. So we will multiply it by 4. Okay, so we have 3.576. Okay, so 3.576. I'll just put it in black. 3.576. Alright, so para naman dito sa next one, C2H6, ang ating ethane. We have 0.05 times how many hydrogen we have? 6. So you have to multiply this by 6. So we have 0.3. How about our propane? So for our propane, we have 0.019. Multiply this to the number of hydrogen. How many hydrogen we have? 8. So multiply this by 8. We have 0.152. Okay? So dito sa ating isobutane, we have 0.004 times how many hydrogen we have? 10. So multiply this by 10. We have 0.04. Okay, and then again we have 0.006 times, okay, how many hydrogen we have? 10. So we have 0.06. Okay, so in here, as you can see, wala naman tayong hydrogen sa CO2 at wala ring hydrogen sa N2. So these are 0. Alright, so kunin natin yung total hydrogen natin. So we will add all of these values na naandito. So we have 3.576 plus 0.3 plus 0.152 plus 0.04 plus 0.06. So total natin 4.128. Or 4.128. Okay, so that's our total. 4.128. Alright, so alam na natin ngayon yung total hydrogen natin. So mau-convert natin kung gaano karaming water ang mapo-form dito, no? So yan naman ang kailangan kasi natin for the net calorific value. So moles of water from fuel combustion. So kailangan makuha natin yan. So how are you going to get the moles of water, no? So we will now start solving for the net calorific value. Okay, so sabi natin, ano nga yung formula natin for net calorific value? We have NCV is equal to our gross calorific value minus, okay, so yung moles of water. Okay, so moles of water from fuel combustion. Okay, FC na lang kasi di kasya, no? Then over total number of moles sa ating fuel. Okay, then we will multiply that to the LC of water. Okay, so again, yung LC natin is yung latent heat of condensation natin. Okay, so alam natin yung GCV pero hindi natin alam yung moles of water natin dito. Okay, so how are we going to solve for that? So let us try to solve for the total moles. Ulat ko lang yung sinosolve natin, ha. Total moles of water form. Okay, so in order to get how much or how many moles of water form, we know that for every mole of water, which is H2O, there is 2 moles of hydrogen, di ba? So tatandaan natin, ang value na nakuha natin is single hydrogen, so it's not H2. Okay? So that means we need to divide this by 2. So this is hydrogen. So we need 2 moles of hydrogen for every 1 mole of water. So therefore, we need to divide that by 2. So therefore, our value of at H, no? At hydrogen, yung nakuha natin, we need to divide that by 2. So our at H, okay, itong ating value, which is 4.128. 4.128, we need to divide that by 2. And that will be our total moles of water formed. Okay, so ilan ba yan? So, we have 4.128 divided by 2, which is equal to 2.064. Okay, 2.064 a kilogram mole of water. Okay? So, nakuha na natin yung ating moles of water. Yung total mole of fuel naman natin, alam natin yan. This is our basis, no? So, this is 1 kilogram mole. And yung LC ng water, kanina, pinakita na natin yan, ano, sa ating given dito. Our LC of water is this, 44.04 megajoule per kilogram mole of water. Okay? So, we know the value of LC. This is 44.04 megajoule per kilogram mole of water. Diba? Okay. So, makukuha na natin yung value ng ating NCV. Okay. So, let us write here. Our NCV is equal to our GCV, our Gross Calorific Value, which is 945.52. So, 945.52. Then, minus, okay, minus, itong moles of water formed. Nakuha na natin yan, 2.064. 2.064 over our total mole of fuel, which is 1 kilogram mole. And then, we will multiply it to the latent heat of condensation ng water, which is 44.04. Okay? So, that will be our net calorific value. Okay? So, let us solve for that. So, unahin ko na to para hindi ako malito. Alright, so we have 945.52 minus 2.064 times 44.04. And this is equal to 854. Okay, 854.62. Okay, 0.62. So this is in megajoule per kilogram mole, no? Okay, so nakuha na rin natin yung ating net calorific value. Okay, so basically alam na natin how to get our GCV and NCV. So itong promise ko sa inyo, kukunin natin itong megajoule per kilogram. So kunin muna natin yung molecular weight ng bawat component natin. So ano yung molecular weight ng ating methane, CH4, so 12 plus 4, this is 16. Ating ethane, C2H6, this is equal to 30, 24 plus 6, this is 30. For our C3H8, this is equal to 44. For our isobutane, this is equal to 58. Ito yung mga molecular weight, guys, no? So, you can also calculate it yourself if you have some doubt about this one. For our N-butane, this is also 58. For our CO2, okay, this is 44. Okay. For our N2, this is 28. So, alam natin yan, ano? So, now, we don't need to get the total. Ang kailangan natin is i-multiply itong molecular weight natin sa mole fraction. Okay, so let us start. Okay, lagay ko to sa gitna para kitang-kita natin yung mga values ng ating mole fraction and molecular weight. So, unahin natin itong CH4. We have 0.894 times the molecular weight 16. This is equal to 14.304. Okay. Next is itong C2H6. We have 0.05 times 30, which is equal to 1.5. Okay. Next, C3H8, we have 0.019 times 44. We have 0.836. Next, we have 0.004 times 58 is equal to 0.232. Okay, so yun sa book guys, iba yung values na nakasulat dito. I think there's an error. And then para sa ating N-butane, we have 0.006 times 58. We have 0.348. Para sa ating CO2, we have 0.007 times 44. We have 0.308. And then, para sa ating N2, we have 0.02 times 28. We have 0.56. Okay, so if I'm going to add all of this, you will get the average molecular weight ng ating natural gas. Okay, so that's what we're going to do here. We will add everything. So 14.304 plus 1.5 plus 0.836 plus 0.232 plus 0.348 plus 0.308 plus 0.56, and this is equal to 18.088. Okay? So, kung makikita nyo sa book guys, iba yung value nito. Okay? Because ang nasa book, this value is 0.348. Where there is an error on that, the correct answer is 0.232, no? And as you can see, kapag inad natin, our total molecular, average molecular weight is 18.088 and nasa book is pareho rin. Okay, so that means mali yung naisulat dito sa book. Okay, so our average molecular weight is, okay, I'll just write here, is equal to 18.088 kilogram per kilogram mole. Okay, so now we will apply that here. Kailangan natin makuha yung megajoule per kilogram. So, we have 945.52 megajoule per kilogram mole. Okay, so this is in megajoule per kilogram mole. Okay, so if it's okay to you, alisin ko na to, no? Kasi we need the space. Anyway, given naman na yan sa ating lecture kanina, no? So, now we can calculate for our requirement, megajoule per kilogram. So, what we need to do is to divide it to our molecular weight. So, we have 18.088 kilogram per 1 kilogram mole. Okay? So, maka-cancel out ang ating kilogram mole. Ang may iwan sa atin is yung megajoule per kilogram. Okay? So, what do we have here? 945.52 0.52 divided by 18.088. Okay, so we have here 52.27, okay, megajoule per kilogram. Okay, so this is our final answer. So yung iba, di na natin sasagutan. Okay, some of it are just conversion, and one of these you will use one-to-one equation. Okay, so you can just find it, no? So ngayon, our focus for this lecture is to show you how can you get the gross calorific value and the net calorific value. So I hope this lesson is helpful to you. And as I said earlier, dito ko yung kinuha sa book na to, and it's a really good book. So if you can find it in the library or in the bookstore, so it will be very useful if you are studying chemical engineering calculation.